How's it going, everybody? And welcome back to our Cisco Enterprise series. In this video, we're going to be walking through all of the things that you need to know about forming EIGRP adjacencies. Now, I'm actually re-recording this video because I wasn't really happy with the first one that came out with. And I've already actually got EIGRP fully operational in our lab. So the video that I recorded that's at the implementation, it does go through some of these details, but as I was reading through my notes again, I was like, I need to go through more detail. So I figured the first video I did came out really good, or I'm sorry, the video where I implement EIGRP, the next video, came out really, really good. But as I was reviewing my notes, I was like, I could do better with the more the theory side, stuff that you actually need to know, not necessarily the configuration commands. That's the easy part. It's understanding all the theory that can be complicated. So going back over here to our blueprint, this is going to be understanding how the adjacency actually forms and all that good stuff that goes along with that. So I wanted to put a bullet point to that. Okay, so let me go ahead and get out of the way, and we're going to start digging into this and break down what's needed and all that type of stuff. And again, I will be sharing this out. So if you're like scrambling to write it all down, there will be a link in the description of the video that will allow you to download this. So forming adjacencies with the network command. There's two different ways that you can form adjacencies. The first is with the network command. The other one is with the neighbor command. So with the network command, it controls which interfaces are running the EIGRP process. However, it does not control which networks are being advertised. So that's one thing that I want to elaborate a little bit. So with your IGPs, OSPF, EIGRP, and RIP on iOS, when you go to enable routing on for a particular routing protocol, the network statement determines which interfaces are going to run that protocol. With BGP, if you want to form a BGP peering, whether it's external or internal, you use the neighbor command to do that. And then once you form that BGP peering, then there is the route advertisement piece of it. So there's two stages to BGP. The network command in BGP determines what gets advertised into BGP, not which interfaces are going to run BGP. So I want to make a clear delineation because that's a major difference between the two different protocols. So I just wanted to call that out real quick. So just remember, whatever the network statement is, that is going to be which interfaces on that particular device are going to be enabled to run EIGRP, and more specifically, which interfaces are you going to allow EIGRP to send out the hello of 224.0.0.10 out on that particular interface, that LAN segment. That's where that comes into play. So it is used to form adjacencies that use the multicast address of 224.0.0.10 to form the adjacency. So the way that I broke this down is like this. Network 155.1.45.5.0.0.0.0 means only the interface with 155.1.45.5 will run the EIGRP process and be able to form adjacencies. So if you use a wildcard mask of all zeros, and we'll talk about the wildcard again, even though I've already, in the upcoming video, I talk about this, but I'm going to reiterate it here. If you use a quad 0 wildcard, that means you're only going to enable that for a /32 route. So it is remember, a wildcard mask is the opposite of a subnet mask. So you have a subnet mask right here, 255.255.255.0. That is going to be indicative of a /24 subnet mask, where a wildcard is the binary opposite of a subnet. So you're saying 0.0.0.255. So when you're saying this, a wildcard specifically says wherever there's a 0, those particular octets must match. So if I type in 155.1.45.0, 0.0.0.255, the first three octets of my wildcard, I must find an interface that matches 155.1.45. Those have got to match. So anytime you see a 0 in the wildcard, means that whatever this octet has for it with the IP address must be the same on that interface. The more specific you are in the fourth octet will determine potentially which interface you enable EIGRP on, because you might have scenarios where you have a /27 or /26 or /29. So the more loose you are with your wildcard, meaning the higher this number goes, if you're in the third octet and you're saying like a 15.255, which means you're looking at like a 16-bit or a /20 for from a binary perspective, you're looking at like summarization and things like that, means you're going to be enabling EIGRP on as many interfaces that would be included in that range. So if you understand, say 10.1.0 through 15 would be, you'd be able to use a 15 range in your wildcard mask, and you'd be able to enable EIGRP on all 16/24s. So that's how that works. If you understand how subnetting works, the wildcard mask is the opposite. And if you're not sure what the wildcard mask should be, the math is very, very simple. All you have to do is take all 255s for what would be the subnet mask, not necessarily a host route, but specifically all 255s, and then subtract the subnet mask of that particular interface. So if you take 255, 255, 255, 224, a /27, and you were to go in here 0.0.0.31, this right here would be your wildcard. So you would plug in 0.0.0.31, which would indicate that you're going to match on the first /27 of this subnet. That's essentially how that would come into play. The wildcard mask determines how much of the network matters. So again, 0 means it must match. So the first 3 octets must be 155, 145. 255 means it doesn't matter. And because it will vary from interface to interface and device to device. So there will always be, if you're looking at a non-host route, so a non/32, it's going to vary. It could be anything inside of that range will get the job done. As long as your wildcard has been correctly formatted, it doesn't really matter what the IP address is. But if you do care, and I've seen environments where they do this for everything, and yes, that does work. However, in most cases, you're not going to do that. You're going to do a /24 or you're going to do a /30 or whatever it might be. So that's how the network command works. Again, it is going to enable EIGRP on a particular interface and allow that interface to send and receive EIGRP hellos on that interface, not advertise subnets into the routing protocol. Keep that in the back of your mind. Now the neighbor command. Use the neighbor command outgoing interface command. So this command alone under the routing process will not form an adjacency. However, can be used to form adjacencies with other routers if multicast isn't available for transit. So if you need to form a unicast adjacency for whatever reason, so this is typically, I haven't seen this used in a very, very long time, but the one time that I did see it in production is when a frame relay circuit did not have multicast enabled on it. And it's been a long time since I've dealt with multicast, but by default, you have to basically turn off the capability of multicast or broadcast capabilities on a frame relay circuit. So if you want it to be unicast only, and I can't think of any other scenario, at least off the top of my head, where you'd want to use this. Now, EIGRP has this cool capability known as EIGRP over the top, or OTP, and it is a DMVPN-like operation. It's built into the protocol. I've only demoed it. I've only messed around with it. I've never actually seen it deployed in production. But if you have a scenario where the underlying infrastructure doesn't support multicast for whatever reason, the neighbor command can be used to get you an adjacency over the top, or over that, whatever the transport is. But if you're dealing with Ethernet, you're going to be dealing with multicast because it's inherently built in. So just be aware of that. Neighbor command is unicast adjacency. Network statement is multicast adjacency. for discovery. Neighbor, you're specifically telling it which IP address you want to form a peering with. So you do have a couple of additional options, like you can associate a description, and then with the neighbor maximum prefix, configure to protect an individual peering session or to protect all peering sessions. So if you learn too many prefixes, you could tear down the peering session, stuff like that. So if you don't have that issue, then don't worry about it. Neighbors are discovered with the hello packets sent to 224.0.0.10 from the primary IP address. That's kind of important here. So one thing to note is you cannot form neighborships with secondary IPs. So if you've never seen what a secondary IP is, if you were to literally type in IP address 10.1.1.1/24 and then hit the question mark, space bar question mark, you might see the term secondary, and I'll give you an example of what that might look like. So if I'm here on R61 and I go to global config, do show IP interface brief, I go to interface gig 1 and I type in IP address here 10.1.1.1/24, I come over here, you see the secondary command. If I was to type in a network statement for 10.1.1.1 and then go to the opposite router on that particular interface and do the exact same thing, you won't form an EIGRP adjacency on secondary interfaces or secondary IP addresses on an interface. It doesn't work that way. So just keep that in the back of your mind. If you do have secondaries, you won't be able to form adjacencies from the secondary IP, only the primary interface IP. I'm sorry, the primary IP on the interface. So some of the things that the neighbors must agree on is going to be the subnet, the autonomous system number, the authentication, and the metric weightings, or the K values. So the K values, and I briefly mentioned this previously, but the K values are how EIGRP is going to determine how to calculate dual. Now, dual, the diffusing update algorithm, this is going to be the algorithm that EIGRP uses to figure out how to calculate the composite metric. The composite metric is what you're ultimately looking for. You're looking for the combination, that's why they call it composite, because there's more than two variables that go into this. You're looking for the composite metric of the bandwidth and the delay. Those are the two default EIGRP K values or metrics that EIGRP uses to calculate dual, or calculate the composite metric via dual. Now, you can change this. You can add things in, like you can add load, you can add reliability, you can add MTU. They're not default. Now, there are weightings for these. So like you can turn the K value on, right? Just by simply turning from a 0 to a 1 and things like that. If you change the metric weightings, so you turn a K value on one router, but it's not turned on all of the other routers, what you're going to do is when you form an adjacency, you will automatically see it start squawking a K value mismatch. And if you see that over and over and over again, it means that that device, whoever you're peering to, their K values are incorrect, or they've been calculated incorrectly. And the reason why that matters is because EIGRP, because it doesn't have a database like OSPF and ISIS, it needs to have the same K values turned on, the same metrics turned on, and the same weightings applied. So the weightings meaning you can apply a 1 through a 255 on your K values for your metrics, and the higher the number means the more emphasis that dual is going to take into calculating on that particular K value. Nobody I've ever worked with has ever messed with this. Nobody modifies the K values. You simply turn on EIGRP and away you go. Now there are some use cases that I've read about where if you're dealing with a very, very low speed link, you could take into consideration load. Where if you're dealing with like a fractional T1, remember a T1 is a 1.5 megabit per second connection, 1.544 is a T1. So if you're dealing with a fractional T1, maybe your download is 1.5 meg, and a fractional means you're dealing with a fraction of 1.5 meg. So if you have a fractional upload, let's say you're 1.5 meg down and you're 768 upload, which is basically the split difference between 1.544. So if you've got that scenario in place, you could use load and say if this particular circuit is loaded at 50% or something like that, then that could be it kind of takes EIGRP and makes it a little bit more real-time dynamic, because now you're saying if the load is high, that could be an alternative path, but if this one here is less loaded, go this path instead. So they're trying to make it kind of like Google GPS works, which yes and no, because Google has the ability of taking into consideration all of the other people on the road, and the closer a group of mobile devices are to each other, technically the more congested the roadway is. That's why you go from green, yellow, orange, red when you're driving along, and Google can say, hey, there's a crash here, or there's heavier traffic over here, so let's take you this route instead. It'll save you 3 minutes, something like that. So stuff like that can be useful, and that's kind of where load, if I was going to use any particular K value besides bandwidth and delay, it would be load. How much is that particular circuit or interface being utilized, and then you can use that as kind of a redirect. The drawback to this, though, is that the more K values you turn on that are dynamic, so they can go up and down over a period of time, and they're not always predictable, you can run into what they call EIGRP churn, which means the Dual is constantly calculating the routing table to figure out what the best route's going to be. So, and I don't know exactly what the scan timer is. BGP's got a 1 minute scan timer. I don't remember what EIGRP is off the top of my head. But if you're calculating EIGRP often, it might make more sense to just ECMP the routes and remove load as the possibility. But load would be the only other one that I could think of that would sort of make sense. But I've never seen anybody actually use it. So just keep that in the back of your mind when you're talking about metric weightings, and make sure that all the K values across the board are the same, so that all the routers in your EIGRP AS are calculating dual the exact same way with the exact same metric weightings, and you won't run into any problems. We'll take a look at K value mismatch in an upcoming video, but just be aware of how that works. Now, the neighbors do not need to agree on the timers, and by default, EIGRP has a 5-second hello and a 15-second dead interval. So you can have it, 7 and 8. I forget what there's specifics that you can do it with. But unlike OSPF and IS-IS, where OSPF is a 10-second hello and a 40-second dead interval, or the dead interval is 4 times the hello. One of the things that EIGRP will do once neighbors are found, EIGRP update messages used to exchange routes. So it'll use multicast to discover, and then it'll use reliable. So it'll try to multicast the updates, and if it can't, it'll default back to unicast. In most cases, you won't have to worry about that. Now the hello multicast to 224.0.0.10 by default, but can be configured to be unicast with the neighbor statement. Remember, I talked about that right up here. If you use the neighbor statement, you're going unicast. Now this contains parameters like the K values and the AAS number. And if you were dealing with a broadcast segment, you are going to send a hello every 5 seconds or 60 seconds depending on the link type. Broadcast is 5-second hello and 15-second hold. NBMA, non-broadcast multi-access, is going to be a 60-second hello and a 180-second hold. What is NBMA? Frame relay. That was an NBMA type of interface. Now, the cool thing about it is we don't have to deal with serialized or TDM, time division multiplexing interfaces anymore. At least nothing in the recent past. I can't say that I've seen frame relay in probably 10 years. I haven't seen a frame relay circuit. Not to say that they're not out there. I just haven't run across them. If you have, great. Put your 2 cents in the comment section below and what you had to deal with, and maybe share your experience and stuff like that. So try to share the knowledge. But if you're dealing with OSPF does the exact same thing. It's all a 60-second hello and a 180-second hold time. So NBMA, non-broadcast multi-access. Non-broadcast is the key piece. Remember I was talking about the neighbor statement where you could form a peering via unicast. If you turn off multicast capability or broadcast capabilities in frame relay, you have no choice but to use the neighbor statement. So I don't demo that anymore. Back when I was still working with GNS3 and serial interfaces were there, and I'd use the router as a frame relay switch, and then I used the built-in frame switch. Back when I was studying for CCIE a long time ago, I used to demo that a lot. But the CCIE lab that I took, we never had frame relay. There were still serial interfaces, but they were point-to-point protocol over Ethernet or PPPoE. And I don't talk about PPPoE either, because it's not on the exams anymore. Everything nowadays is high-speed circuits and stuff like that. You guys are kind of lucky. I was told I was lucky with virtualization for studying with, but you guys are kind of lucky because you don't have to deal with any of that stuff. So that's where that comes into play. So when it comes to update messages, we're going to talk a little bit about some of the capabilities that are out there and all the stuff that goes along with that. So update messages describe attributes of a route. And you'll see this in the next video where I go through and I look at how EIGRP, the frame format, and we look at it in Wireshark. So you're going to have the prefix and the length. Remember, this is going to be your subnet and the mask, essentially. The next hop value, what IP address are you going to point to get to wherever you got to go. The bandwidth, the delay, the load, the reliability, the MTU, the hop count. Because, that's another thing now that I'm thinking about it. EIGRP's width, by default, is 100 hops. We talked briefly about this with RIP. RIP has a maximum usable topology size of 15 hops. It wasn't meant to be very big. Where EIGRP by default stops at 100 hops. So you can calculate up to 100 EIGRP in serial or in line neighbors. Well, routers, each one forming a neighbor with each other. I've never demoed anything like that before, but if you want to go beyond that, you can increase your hop count if you would like to do so. There are external and internal attributes, so you have the EIGRP router ID. Now, one of the things that all dynamic routing protocols do is they set a router ID. And this is a unique value per box that is used to prevent route feedback or prevent loops. So if you receive your router ID, you will discard the update to prevent a loop. The idea is this. If I'm Rob and I have a router ID of 1.1.1.1, and I send an update out to the rest of the network, I'm going to include my router ID in the update. That's my unique identifier in the EIGRP autonomous system. I send that out to the rest of the world, and let's say I get a route back. Because this is where EIGRP can be interesting with the concept of routing by rumor, because there is no consistent database used with EIGRP. It is you only learn what your directly connected neighbors tell you about. So if my neighbor tells me about a route that he learned from somebody else, remember that telephone game I was talking about in a previous video, where you're, trying to say something, your teacher tells another student of yours, or another classmate of yours that, Sally sells seashells by the seashore, and it doesn't come out that way when you get to it. When you get that information back in, if you see your router ID in the EIGRP update, that means that you originated that route. You're going to drop it because you already know about it. So if you see your router ID, any updates that come with that router ID attached to it, you're just going to go ahead and drop. Some of the different things that you're going to see is going to be the acknowledgement. The acknowledgements are acknowledges receipt of an update, query, and reply messages via unicast. Uses the same opcode as hello. So if you receive an update from somebody, you're going to acknowledge it back to them. That's where the reliability piece comes into play. Then you have a query. Used to query neighbors to find paths to a destination. So multicast to all neighboring routers initially, but unicast if multicast fails. Each query should be acknowledged and answered with a reply. This goes back to that thing I was talking about with the stuck and active. If a network goes down somewhere in the EIGRP AS, whoever that device, whatever router that particular network was attached to, will ask all the other EIGRP neighbors, do you have an idea, do you have another path to this network? So what will end up happening is every router in the EIGRP AS will get this query, and they have to respond with either yes or no. If it's yes, okay, what is the alternative path? If no, it responds with nope, I don't have a route, so therefore the query domain gets responded to. If the query response, the reply to the query, doesn't come back with inside of the active timer, it goes stuck inactive and the EIGRP adjacency goes down. So keep that in the back of your mind. Now, what is the query mechanism? The query mechanism is this. When a route fails, different things can happen depending on if the router already knows about an alternative path or not. If a feasible successor exists, a feasible successor is always going to be referred to as a backup route. Install the best one in the routing table immediately and send updates to neighbors about the new best path. Fair enough. Which means you already know about it, therefore you don't have to even think about it. You're going to take the feasible successor and you're going to use that route as the new route because the successor that you did have is no longer there. If a feasible successor does not exist, the router has gone into active mode and will query all EIGRP neighbors for the route. Do you have a route to this particular destination? Yes or no? If you don't, so we'll talk about that here in just a second. If the querying router is not the successor, reply with the route information or stating that it does not know about the router. So if you don't know, you don't know. If the querying router is the current successor, queried router lost its successor route. If a feasible successor exists, install the feasible successor route and reply with the new route info. If a feasible successor does not exist, query all neighbors. So you're going to send it out and hopefully you'll get a response back in before the active timer times out. Now, stuck inactive. EIGRP routers must wait for a reply to each query message. In turn, routers queried may need to go active querying their neighbors and also wait for those replies. This can create a domino effect. If a router does not hear a reply within the active period, 3 minutes, the route goes stuck in active state. When a route goes stuck inactive, the router brings down the neighbor relationship with the router that did not reply to the query. So it's a very straightforward process. If you sent out a query and you haven't gotten one back from that neighbor yet, you're going to take down the peering because you're not sure what they've got going on. The reply. Unicast back to the querying router in response to a query for a route, acknowledged with an ACK. So you send a query out and then you get a query reply back in saying yay or nay. So that, ladies and gentlemen, is the basics to how you can go about verifying or how to set up EIGRP adjacencies and things like that. So it's important to know this information. Again, you'll have it. There will be a link in the description to download this if you'd like to read it more thoroughly. I'm barely scratching the surface with what's there. I keep looking down because my microphone is sometimes right there. But that is pretty much what I wanted to cover in this video. The next video, we will dive into actually standing this up. We're going to rehash a little bit of the information, but it'll be important for you guys to see how that actually works out. So with that being said, I want to thank you guys for stopping by and hanging out with me. If you haven't already dropped a comment for a question, concern, something like that, drop a comment in the comment section below. If you haven't already done so, please like, share, and subscribe, and I'll catch all of you fine people in the next video.